Hello. Today we're going to be doing Solver again, and just as a quick reminder, Solver is a tool in Excel that's used for doing optimization problems, and with Solver problems we're going to have an objective. That is the value that we're trying to maximize or minimize. We're going to have some variable cells. These are the things that we're going to change in order to satisfy our objective. And then finally we're going to have some constraints. The constraints are the additional conditions that need to be met while satisfying our objective. And these are the three things that we're going to need to enter for any Solver problem. We also need to make sure when we do a Solver problem that we have our spreadsheet set up correctly, because Solver works on the basis of the formulas that we have in our Excel spreadsheets. Today we're going to do a slightly more complex problem in Solver, and this is a distribution planning problem. This is a very common problem for companies that have different warehouses or distribution centers around the country and different manufacturing facilities. So this is more similar to the shipping, or rather the distribution problem that I talked about with our last lab with Coca-Cola. What we have in this case is we have various facilities that make tennis rackets, and we're shipping these tennis rackets from these facilities to various distribution centers. So we have factories in Seattle, Indianapolis, and Boston. We have distribution centers in Atlanta, Baltimore, Boise, Dallas, Denver, Chicago, New York, and San Diego. And we need to get our tennis rackets, cases of tennis rackets, from our factories to our distribution centers. So the way to read this is Atlanta is a distribution center. It has a demand of 125 cases, so it needs 125 cases of rackets. And we have various shipping costs. So to ship one case from Seattle to Atlanta costs $108.95. To ship a case from Indianapolis to Atlanta costs $21.50. And to ship a case from Boston to Atlanta costs $27.15. We have similar demands and shipping costs for all of our other distribution centers and factories. And so what we want to do is we want to ship our inventory from all of our factories to our distribution centers in a way that's going to satisfy their demand. All right, so if we look across all distribution centers, we have a total demand of 1277. Now in our factories we have a certain amount of inventory. So Seattle has an initial inventory of 500, Indianapolis has an initial inventory of 475, and Boston has an initial inventory of 325. So the question is, how do we ship all of these tennis rackets from these plants to these distribution centers in the most efficient way possible, or in other words, in the most cost-effective manner? So really what we're trying to do here is we're trying to minimize shipping costs. We're going to let Solver do this for us. So first we need to set up the spreadsheet with the appropriate formulas. These gray cells here in the middle are going to be our changing cells. So if we ship, for example, 5 cases from Indianapolis to Atlanta, then here on my Atlanta row, I'm going to, or rather at the intersection of the Atlanta row and the Indianapolis column, I'm going to have a value of 5. And that means that I'm shipping 5 cases from Indianapolis to Atlanta, as an example. So what we need to fill in are these columns over here. The total number shipped and the total costs. All right, so let's say that just to make sure our formulas are working correctly, let's enter a value of 1 in all of these gray cells. All right, so I'm going to put a 1 all over the place here. All right, so total shipped is going to be 3. And so actually, this formula is already put in here for us. So the total shipped is going to be a sum of F5 through I5. So in other words, my total shipped to Atlanta from Seattle, Indianapolis, and Boston is 3. Total shipped to Baltimore from all 3 facilities is 3. All right, so we've got total shipped here, and then we have a sum total at the bottom of 24. Over here, we've got a number shipped from each facility. So if I look at Seattle, I ship 1 to each distribution center. That is a total of 8. Down here, Seattle has an initial inventory of 500. I have shipped 8, and that means I've got 492 remaining. All right, so that's what these cells are for. All right. Lastly, I've got to deal with costs because costs are what I'm really trying to work with here. So, what is the total cost of all of these shipments to Atlanta? Well, to ship one case from Seattle to Atlanta costs $108.95. To do another one from Indianapolis to Atlanta costs $21.50, and to do another one from Boston to Atlanta costs $27.15. So one way to figure out what the total cost would be to do a complex sort of multiplication and addition problem. So I could say F5 times C5, that would be Seattle, plus G5 times D5, that would be Indianapolis, plus H5 times E5. Okay, so I'm calculating the shipping cost for each factory and then adding them up. And that gives me a cost of $157.60. So that's one way to do it. A more efficient way to do it is to use a new formula called sum product. And sum product does sort of what the name implies. It creates a sum of products. So this is like matrix algebra. What you do here is you multiply one set of cells times another set of cells and add them up. So I'm going to type in sum product, and then I'm going to say C5 through D5, or I'm sorry, C5 through E5. That's my first array. And then my second array is F5 through H5. All right, so it's going to take the 3 values in C5 through E5 and the 3 values in F5 through H5, and it's going to add them up. And so I come up with the same answer, 157.60. Then if I take the sum product formula, copy it down my column, I get the total costs for each of the distribution centers. Okay, so to ship all of this from these 3 factories to Atlanta costs $157.60, and so forth, giving me a total cost of $1,321.60. Okay, so that should be all we need to set up, all we should need to do to set up the spreadsheet. Now we're ready to go into Solver. But one thing that is different here is we don't have the constraints laid out for us like we did before. So what are our constraints here? Well, we have a demand constraint in that each plant, or I'm sorry, each distribution center has a certain amount of demand. So when we do all these shipments, we have to ship at least 125 to Atlanta. We have to ship at least 187 to Baltimore, and so forth. Okay, so we have demand constraints. We also have supply constraints. Each plant has an initial inventory and we cannot ship any more than what is initially in inventory. Okay, so that's our supply constraint. And what we're going to try to do is we're going to try to minimize costs. So we want to satisfy all this demand using all of this supply, and we want to do it in a way that minimizes costs. So that's what we're going to do in Solver. So I'm going to go to the data menu. So at this point, I'm going to go into Solver. All right. Here's my Solver parameters box. The first thing I'm going to put in is my objective cell. My objective cell is total costs. So that is cell K13. And the default is to maximize. That's what we did in our other Solver lab. This time we want to minimize. We want to minimize total costs. All right, now we've got variable cells. All right, last time we had just 2 variable cells, the number of Model 1 and the number of Model 2 tennis rackets. This time we've got 24 variable cells. Okay, so all of these here from F5 through H12 are going to be our variable cells. So Solver is going to manipulate those values until it comes up with the correct solution. And then lastly, we have constraints. Okay, so my constraints are going to be my demand constraints and my supply constraints. So I'm going to add a demand constraint, my demand constraints first. I'm going to click on Add, and I'm going to say B5 through B12. Okay, so these here, those are my demand constraints, have to be less than, or actually, so I'm going to add a demand constraint. My demand constraint is the total number that I ship to each of these facilities. So in other words, J5 through J12 has to be less than, or I'm sorry, I'm going to change this, greater than or equal to these demands over here. So B5 through B12. All right, so J5 through J12 has to be greater than or equal to B5 through B12. That's going to be first. Second constraint is the number that I ship here has to be less than or equal to the amount of initial inventory down here. So my total shipped, F13 through H13, has to be less than or equal to my initial inventory, F15 through H15. And then lastly, I'm going to put in an integer constraint. My integer constraint is going to say I can only ship whole cases. Okay, so I'm not going to ship any partial cases from my factories to my distribution centers. And then I will say OK. I'm going to change my solving method to simplex LP. And then I'm going to hit solve. All right, my answer, Solver found a solution. All constraints and optimality conditions are satisfied. And I'm going to say OK. All right, now let's look at our solution real quick. My total costs are $50,062.40. If I look at the total shipped to each of my distribution centers, it matches. So all the values in column J match the values in column B. And if I look at the number shipped from each facility, I can see that I shipped 477 out of Seattle. I've got 500 units, or I started with 500 units, so I've got 23 left. I've shipped 475 out of Indianapolis. That means I have 0 left there. And I've shipped 325 out of Boston. That also means I have 0 left there. So in total, I've shipped 1,277. I have 23 left in inventory. Those are in Seattle. Let's look at some of these costs real quick. So if I look at Atlanta, shipping costs from Seattle to Atlanta are $108.95. That's pretty high. So probably shipping from Seattle to Atlanta doesn't make any sense. If I look at Indianapolis, it's only $21.50, and if I look at Boston, it's $27.15. So it's cheapest to ship from Indianapolis to Atlanta. However, if I look at what Solver came up with, it has shipped $125 to Atlanta from Boston. Okay, even though Indianapolis is cheaper. And so the question is, well, okay, why is that? Why did Solver choose to do that? Well, if you go and look at New York, New York is the same. So to ship from Seattle to New York is very expensive. To ship from Indianapolis to New York is much cheaper, and to ship from Boston to New York is also cheaper. But it's still cheaper to ship from Indianapolis to New York than to ship from Boston to New York. However, in Atlanta, the difference between Indianapolis and Boston is only about $6, whereas in New York, that difference is about $23. So it's more efficient to ship from Indianapolis to New York than it is to ship from Indianapolis to Atlanta, because the price difference is much greater in New York. So in terms of overall costs, it's cheapest to evaluate it to allocate the inventory in this way. So those are the types of things that Solver can think of and evaluate when it's coming up with solutions that are difficult for people to do, because there are so many possibilities here with the different combinations of plants and distribution centers. All right, now let's change the problem a little bit. Let's say that the San Diego distribution center just got a huge order in from somebody, and so they have said our demand isn't going to be $125, it's going to be $175. Or I'm sorry, units, 175 units. So San Diego's changing its demand to 175. All right, well, notice what happens. When we change that demand, then the total demand is 1,327 units. If we look at the initial inventory, however, the initial inventory is only 1,300 units. And so that means that we do not have enough cases in inventory to satisfy all that demand. And so now, if we clear this out, and we ask Solver to solve this problem, it's going to tell us that it can't. Okay, I can't solve this problem because one of my constraints, my demand constraint, conflicts with my supply constraint. And so it says I can't find a feasible solution. However, it seems like we should be able to find a solution that will let us ship the 1,300 that we do have in the most efficient way possible. And so there's two ways to do that. One is just to tell the San Diego people, well, too bad, you can't have 175. All right, but that may not be the cheapest solution. It may be cheaper to give them the 175 and tell somebody else that they can't have all of their demand. All right, so to come up with a solution in this case where we have conflicting constraints, what we're going to do is we're going to come up with an imaginary plant. And so you may have noticed I have this column I here, which is right now empty. Let's say that this is going to be our Fantasyland plant. All right, so we've got an imaginary plant, and we're going to put 27 units of inventory in this plant. All right, so the initial inventory of this plant is 27 units. All right, so now with these 27 imaginary units, now we have a total initial inventory of 1327. And we have a total demand of 1327, so now we can have Solver do this problem for us and it'll come up with a solution. All right, so a couple things I need to change. Number one, I need to change my total shipped. Oh, no, I don't. Total shipped is already correct because total shipped is adding up F5 through I5. So my total shipped already includes Fantasyland here, which is what I want. I'm going to look at this sum of I5 through I12. That's also correct. I don't need to change my cost column because when I ship stuff from Fantasyland, it's not real, so I'm not actually incurring any costs. Okay, so that's not going to change. I know this seems weird, but it'll all make sense when we get a solution, I think. So I'm going to clear this out. I'm going to come up to Solver. All right, so my objective is the same, K13, minimizing total costs. This time my variable cells are going to be F5 through I12. Okay, so I'm going to change that H to an I. And then my constraints. My constraints are going to be are going to need to be changed a little bit. So to change a constraint, I select one and say change. I'm going to change this constraint, so instead of F13 through H13, I'm going to change that to be F13 through I13. Let me make sure I've got this right. F13 through I13. And that is going to be less than or equal to F13 through F15 through I15. Click on OK. And then my supply constraint. Actually, no, that's going to stay the same. J5 through J12 is greater than or equal to B5 through B12. So the only constraint I needed to change was my supply constraint. All right. Now I'm going to say solve. Okay. Now Solver found a solution. Okay, I'll say OK. All right. Now let's look at this. I have shipped 1,327 units. Sorry, I got a couple of phone interruptions there. So looking over this, total demand of 1,327, total supply of 1,327, so that matches. My shipping costs are $49,724, so curiously that's actually a little bit lower than it was before. And if we look over our number shipped, this time we're still shipping from Boston to Atlanta. These numbers have changed slightly, and now San Diego is getting 175 units. So it's getting all 175 units from Seattle. Now let's look at New York. New York is getting 223 units from Indianapolis, and they're getting 27 units from Fantasyland. All right, so what this really means is New York has a demand of 250, and they're only going to get 223. So New York is going to get the shaft on the inventory shortage. Okay, they're going to get slightly less than they wanted because these 27 units that we're shipping from Fantasyland, of course, are imaginary. So why did we go through all this? We went through all this so that we could get Solver to give us a solution. Okay, even though we have two conflicting constraints, we get around those constraints by creating this imaginary inventory. Okay, so in this situation, New York is getting shorted, even though San Diego is the one that asked for the extra inventory at the last minute.